systems symbolically. So the first one we're going to look at is substitution. So the steps for substitution, we want to solve one equation for one of the variables, substitute it into the second equation, solve, and then substitute that value into equation from step 1. So let's take a look at our first example. I have y equals, so I want to take what y equals and I want to substitute it in for my second equation where y is. So that means I have 2 times x minus 3, but I'm substituting my y in for 12 minus x. So that means that, equals 6. So from here, in order to solve, I need to distribute that negative 3. So when we distribute our negative 3, so I'll have 2x, negative 3 times 12 is a negative 36, and negative 3 times a negative x is a positive 3x equals 6. So if we look at our like terms, 2x plus 3x means we have 5x minus 36 equals 6. So I can add 36 to both sides. So if I take 36 and we add 6, I'm going to end up with 42. Divide both sides by 5. So 42 divided by 5 is 8.4. So that's what x equals. But in order to solve this, we also have to solve for y. So if I take my first equation, y equals 12 minus x, but I know what my x is now. So I can do 12 minus 8.4. So when we have 12 minus 8.4, y equals 3 6/10. So our final solution is x is 8 4/10, and y is 3 6/10. Alright, so now let's take a look at our second example of substitution. So I know here's what y equals, and I'm going to be replacing and substituting it in for my second equation. So instead of y, I have 3x plus 8 equals 2x plus 6. So if I subtract 2x to both sides, I end up with 1x plus 8 equals 6. Subtract 8 to both sides, x equals a negative 2. So now I have to plug it into my second equation. So y equals 3 times a negative 2 plus 8. 3 times negative 2 is a negative 6. And negative 6 plus 8 is 2. So my final solution is negative 2, 2. Alright, let's look at solving elimination. So in elimination, we want to get one variable to be opposites. We want to add the equations together, so one is eliminated, and we want to solve for the remaining variable and plug back into either equation to find the second variable. So if I take a look right now, I can easily eliminate my y's because negative 2y plus 2y is 0, so they cancel each other out. So 3x plus 2x is 5x. 14 plus 6 is 20. So divide both sides by 5. X equals 4. So then to find my y, I'm going to pick the top equation. I'm going to plug in what my x is, which is 4, minus 2y equals 14. So 3 times 4 is 12. Subtract 12 to both sides. So negative 2y equals 2. And we divide both sides by a negative 2. Y equals a negative 1. So my final solution is 4, negative 1. Okay, so let's take a look at this next one. So if I look at both my x's and my y's, right now I can't eliminate either one because nothing will add together to be 0. So if I take and multiply this bottom equation by 2 and distribute it to everything in there, that means this one stays the same. We still have 6x minus 12y equals negative 18. But when I distribute 2 times a negative 3x is a negative 6x. 2 times 6y is 12y. And 2 times 8 is 16. So now my x is actually 6x minus 6x is 0. Those cancel out. Negative 12y plus 12y, those cancel each other out. So we're left with 0 on the left side. and negative 18 plus 16 is a negative 2. So in this case, 0 does not equal negative 2. So there is no solution to this problem.